Okay, we're going to look at 6.4, so analyzing graphs of quadratic functions. And we're starting out with the quadratic function y equals x squared plus 4x plus 3. And so it says for each function, find all the necessary information there. So first thing we need is the vertex. So finding that vertex and axis of symmetry, if we look back at our notes from 6.3, in this standard form, vertex would be negative b over 2a, and then plugging that number into the formula and solving it. So first of all, let's label our a, b, and c. So a, remember there's an invisible 1 that shows up in front of that x squared. So a would be 1. B is a 4. And c is 3. So to find my vertex and my axis of symmetry, start out with x equals negative b, so negative 4 over 2a. The 2 times 1, which would just be 2. I'll simplify that out. Negative 4 divided by 2 leaves me with a negative 2. So that gives me, at least my axis of symmetry is going to be the line x equals negative 2. And then I know that my x value for my vertex is going to be a negative 2. Next thing I need to do is plug in my x value of negative 2 into the formula and solve for y. So y equals negative 2, and remember that negative is going to be inside the parentheses with the 2, squared, plus 4 times negative 2, plus 3. So negative 2 squared, the negative 2 times negative 2, which gives me 4. Negative 2 times 4 gives me a negative 8. And then the positive 3 just drops down. So 4 minus 8 gives me a negative 4, plus 3 ends up at a negative 1. So my y value equals negative 1. And that finishes out our vertex. So when I'm looking at that, I know my vertex is at negative 2, negative 1. And then from there, we can plug this in to our calculator and the y equals. So y equals x squared plus 4x plus 3. And I can take a peek at what the graph looks like here, but what I'm really looking for is this table. So second table, and I'm going to scroll down to my negative 2, and I'll kind of put that in the middle there. So negative 2, negative 1 is there. That's my vertex. And if I look, that's my lowest point. So let's fill in some values here. Negative 1 and 0, negative 3, negative 4. So when it's at negative 1, it would be 0. And when it's at 0, it would be 3. And same thing going up. Put a 0 and a 3 there. So already looking at those numbers, the y values, it looks like I'm going to a certain point at the bottom. So it's going to be a minimum value. And we'll say that's minimum values y is negative 1. And let's go ahead and graph that. We've got our table. Let's start out at negative 2, negative 1. -1, 0, and 0, 3. And looking at my other chart, when I was at +1, it was up here at 8. So we could go ahead and put that point. Then we'll do our symmetrical dots on the other side. And we've got our parabolic shape there. Our axis of symmetry going through the middle there. Now it wants to know our domain and range. So looking at my domain would be my x values. If I try to put a constraint here on the left side, I hit an arrow, which means that's going to keep on going forever and ever. And even though it doesn't go out to the left very much, it's never going to stop, so it'll continue on. And then I look at the right side, same thing, I hit an arrow, so it's going to continue on, going up and outwards forever and ever. So my domain there, looks like it'll just be all real numbers. So that's my R for all real numbers. And if I look at my range, I have, starting up top, I could keep on going forever and ever. You've got Y values that are here and here and here, and so we're getting smaller and smaller as we go up, still hitting Y values as I go. But I get to a point where once I'm right here, I stop hitting any Y values and there's nothing left. So if I look at the place that I was able to highlight where there are some Y values, everything is above this line right here. And if I look, that's where Y equals -1. So we could just say that all of those Y values are greater than or equal to -1. So since I have a minimum, you kind of notice the similarities there. The lowest point is that Y equals -1. Everything is greater than that. Then I need my roots. So my roots is just where it crosses the x-axis, or where my Y value is equal to 0. So my roots here would be -3, 0, and -1, 0, which really for us means if we were to factor this, I could factor it and I would get factors of x plus 3 and x plus 1, and that would be the factored form of that equation. So we've got all our information there. Let's look at our next one. So in number 2, we have vertex form, which means, and even though there's not a number back here, just be +0. Doesn't show up there because you don't have to have it. But remember, I'll take the opposite value of what's inside the parentheses with the x and keep the same number there. So -2, change that to the opposite, so +2, 0 would be my vertex. So I can put that dot there. And one thing we know about the vertex is that the axis of symmetry is the vertical line that crosses at that same point. And so now we're ready to take and see about putting that in our calculator. We'll clear out our last one. I'm going to do 3x minus 2 squared. And I don't need to put that +0. And then I'll look at my table. So I'm looking for +2. And again, it looks like that's a minimum, but let's go ahead and fill in a few values first. So I've got 2, 0, 1, 3, and 3, 3. And if I go to 0, it's at 12. So it doesn't really help me from a graphing standpoint there. So on my graph, the only other points I can really put would be 1, 3, and 3, 3. And I just keep in mind that at 4, it's going to land somewhere up there. So I'm graphing it going that way. A pretty steep graph overall. And looks like I have a minimum value again. So that minimum value would be y, where y is equal to 0. And looking at my domain and range, I have a domain again of hitting arrows on both sides. So domain of all real numbers. And my y values, I'm hitting y values continually going down all the way until I get to that 0 there. So we would say that all the y values are greater than or equal to 0, because I've got the point there that's equal to 0, and then anything above that. Last but not least, we've got our roots. And so for this one, it looks like I've got a root of where it crosses the x-axis is just at 2, 0. So that would actually be a double root. That's the only 0, the only root that I've got for that one. Okay, looking at one last one. I've got this one now in root form. So the nice thing about root form is that it's going to go ahead and give me my roots down here. And so really what's happening with those roots is I set each part equal to 0. So x minus 2 equals 0, and x plus 2 equals 0, which ends up giving me x equals 2 and x equals negative 2. So now 2, 0, and negative 2, 0 as my roots. So I can go ahead and put those on the graph here, and that'll give me a little bit more information. So there's negative 2, 0, and 2, 0. So one of the things I know is that those roots are mirrors of each other, and they mirror one another across the axis of symmetry, which means that axis of symmetry is going to be at x equals 0, and that actually gives me the x value of my vertex. So then to find my y value, all I've got to do is plug in a 0 for x into my original formula, and we'll find that y value. So negative 2 times 0 minus 2 times 0 plus 2. So I end up with negative 2 times negative 2 times positive 2. So 2 times 2 is 4, times another 2 is 8. I have a negative and a negative, which would make that a positive 8. So y for my vertex would be a positive 8. And as you probably already figured out, one of these numbers, the x value, gives us the axis of symmetry, and the y value is going to give us our maximum or our minimum. So I put that in over here. Let's see, 0, 8, it'll be way up here. We can already tell by the way my points are facing that it's going to be a maximum instead of a minimum. But let's go ahead and put it in and double check that. Anyways, maybe get a couple more points. So I have -2, x minus 2, x plus 2. And we'll get my table. Make sure that I've got the right vertex there. Everything looks like it's working out. I've got vertex at 0, 8. Then I have my 2 and -2 on there as my roots. So we'll just fill in 0, 1, 2, 0, 6, and 6, and 0. So looks like I've just got those points right there. And I could, if I wanted to, looks like my next point would be a -10. So just gives you a little bit better idea as to the curve of that. So looking at our maximum or minimum, we have a maximum where y is 8. And my domain, as you've probably already noticed here, again, I hit 2 arrows. So my domain, once again, going to be all real numbers. And my range, now I'm looking, I don't have any up at the very top here, but I have a point where I hit y values starting here at +8. And then I'm hitting y values all the way going down. So for this one, y is not going to be, it's not greater than 8. So I have a y and an 8. And it's everything that's smaller than 8. So every y value I have is going to be less than or equal to 8. And we've got everything filled out. You start to notice patterns that a lot of this stems from my vertex, my maximum or minimum value, my axis of symmetry, my range, all kind of stems from there. Then we're just finding the roots, and my domain really is going to be all real numbers each time. So that gets you working on breaking apart those graphs into all that necessary information